Free Algebra, we are starting our final unit of the year, which, as I promised it earlier, is really your springboard into algebra. It's going to be a lot of equation solving, term manipulation, just how do things behave, how do things react with each other in these longer expressions and equations that we're going to be working with. So I'm going to try and get all of our definitions on one page here. I think we can do it like that. Okay. And let's just start not talking about numbers and variables, but about objects. Soccer balls and basketballs. Okay. Now, we could say that I've got a soccer ball and a second soccer ball and a third soccer ball and a fourth soccer ball. Or I could just say I have 4 soccer balls.
4S.
Right? And we could represent that using 4S, okay? S representing how many, or representing a soccer ball. 4 being how many we have, okay? We've talked before about how a coefficient tells us how many of the variable we have, and we have 4 of them. I can't say I've got 7 soccer balls, though, because I don't. I've got a different type here, okay? 3 basketballs. And we could represent that as 3b. So our expression here, rather than having 7 objects all written out, we could simplify it to write it as 4s plus 3b. We can't combine these because they're not what are called like terms. Right? Soccer balls are different than basketballs. Okay? They're not the same thing, so we keep them separate. The next example, we've got lamps, chairs, and beds. How many lamps do we have total there?
2.
We have 2 of them. Okay, we might write that 2L. A little cursive L so we don't think it's a 21, right?
That's like.
What? Would you like me to fix it, Tony?
I'll get confused. Oh no.
2L. There we are. That's better. How might we represent the number of chairs we have? How might we represent the number of chairs we have, Kate? 4C. And how might we represent the number of beds we have? 3B. Okay? And really, at its core, that's all what this unit is going to be about. Okay? It's going to look a lot more complicated than that because we're going to be dealing with variables and fractions and solving. But really, this is how you write an algebraic expression. How many of something do I have? The coefficient tells you how many you have, and the variable represents what that object is. Okay? And each of these individual things is what we call a term. Right? A term is a part of a mathematical statement.
Stop.
What's the problem over there?
No, it was not.
Folks, Blake, Evan, Tony, warnings for all of you. Part of a mathematical statement, and terms are separated by addition and subtraction. Separated by addition and subtraction. Okay? A part of a mathematical statement, terms are separated by addition and subtraction. Yes, sir?
We're going to have one of those vocab quiz thingies.
Might very, very well. We got a lot of vocab.
You said we were going to do those.
So, in our first expression with the soccer balls and the basketballs, Jeffrey, how many terms are in this mathematical statement here? 2. Okay? It has 2 terms. That addition sign separates one term from another. It separates the 4s from the 3b. How many terms do we have in this expression here? 3 terms, right? We have the 2L, we have the 4C, and we have the 3B. Okay? So each one is part of that mathematical statement, and they are separated by addition and subtraction. A coefficient, we've talked about that already today, as well as in the past. What does a coefficient do? What does a coefficient do? Where is it? Maybe start there. Where is it? What does it do? What does it tell us? Tony.
Oh, where is the coefficient?
Sure. I've got 2 lines to fill up here, so we'll, yeah. Where do you find it?
And the equation. I don't know where.
Abby?
It's like the number of soccer balls, it's like 4.
Okay, so it comes before the variable, right? The coefficient is the number before the variable. And what does it tell us? What's its purpose? Why is it there? What does the coefficient in 4S tell us about the soccer balls? What does the coefficient in 3B tell us about the basketballs or the beds? Yeah.
Tells you how many there are.
Right. Tells you how many of the variable you have. Tells you how many of the variable you have. Okay. So the number before the variable tells you how many of the variable you have. And of course, what operation is happening between the coefficient and the variable? 4s plus 3b. What operation is between the 4 and the s and the 3 and the b? Tony?
Or addition?
Nope.
Or multiplication?
Multiplication, right? So we don't write it. It's kind of one of those things that we just understand, okay? But they're really, you could put that, 4 times s, or put the b in parentheses there, right? Any of those things that is shown to use that you're multiplying, you could put there, but we don't, because it's just simpler when we don't. It's less clutter, okay? But it does mean 2 times L plus 4 times C plus 3 times B, and so on and so forth, right? The constants of an equation. We've talked about this before too, way back when we started working with function tables and things like that. Who remembers? Yes. Blast from the past. Who remembers what a constant is? A coefficient is attached to a variable. A constant is just a number, and it has no variable. A number without a variable. We don't need the calculators out right now. You can put those away. Okay. A number without a variable. Like terms, and this really is going to be the focus of the objective today.
Yes.
Okay. This one and the next one. But like terms are terms with the same variable that can be combined. Okay? Terms with the same variable that can be combined. Terms with the same variable that can be combined. Right? I could have written this expression up here to say, well, I've got a chair, or sorry, lamp starts with L. I have a lamp plus a chair plus a lamp plus a chair plus a chair plus a chair plus a bed plus a bed plus a bed. Right? I could have written that expression like that, but that's kind of long, complicated. Okay, I simplified. I combined like terms by saying, well, really, how many lamps do I have? 2 of them, right? How many chairs do I have? 4 of them. How many beds do I have? 3 of them, right? So like terms are those terms that have the same variable that you can combine. Okay, and to simplify is essentially the act of combining like terms. Okay? To simplify an equation is to combine like terms. You ready for this?
No.
Can you do a little?
I think you are.
I'm ready for this.
I think you are. Okay.
Already.
Any definitions, any words I wrote too messily that you want me to go? Yes, Jeffrey.
With like terms, what does it say in the beginning?
Terms
Okay.
with the same variable that can be combined. Terms with the same variable that can be combined.
I think we need to go outside before we do this.
Nope.
I think we should do some stretching for you.
Let's start bouncing off the walls, but don't.
Okay. All right, here we go. Carter, second warning for you. You do not need to move the table that many times. I'm the only one sitting there. Okay. Your job here is to combine the like terms. A couple other identification things also. It says in each expression below, circle the coefficients, box the constants, underline like terms, then simplify the expression. Okay. So let's start by circling the coefficients. What are my coefficients in this expression? Those numbers that come before the Griffin. Give me one.
The 3, 4, and 3x and 4.
So the coefficient, you're right on where to look there. The coefficient is when we just the number, right? The coefficient doesn't include that variable x because x is the variable. Okay. And box the constants. What's my constant here? What's my constant here?
9.
What's my constant here?
Wait.
Abby? Now, you got to be careful here, okay? It's not going to be 9. Evan, warning for you. It's not going to be 9. Haley? -9. That sign belongs to it. I promise you, if you don't look for that, it's going to get you, okay? That subtraction sign is also sneakily a negative sign that belongs to the 9. Yes, sir.
Does that mean?
I was calling on Tony, but
Sorry.
go ahead, Tony.
So for like plus 4x, do we circle the addition sign?
Yes, the plus sign should be included with the 4 there. Okay. And now we want to underline the like terms. Jeffrey, what can we combine here? How can we simplify this expression?
You add 3 to 4.
Right. Instead of saying I've got 3 x's and I have 4 more, why not just say you've got 7? Right? I mean, x represents the same thing. You start with 3 of them, you add 4 more, that's a total of 7. Why don't you put that? Simpler. Right? And our -9 has to follow. We can't subtract 9 from 7x because the -9 doesn't have to do anything with the x's. It does not have that same variable, so it's not a like term. So you have to keep it separate.
So what do you do with it?
Leave it.
Just like that.
And you're done?
Then you're done.
What?
Yeah. Yeah.
So,
Oh my
gosh.
That is crazy.
So,
Okay.
what do you do if there isn't a consonant?
Constant? If there's not a constant, then you don't have anything to worry about. Then you don't have to put anything inside of a box.
Constant.
Constant?
No.
Wait, constants.
Constant.
Folks, 3, 2, 1, you are quiet. What's going on today? Why so much?
Fancy. Anti and the fancy.
Okay. Okay, go ahead. What was your
What do you
Follow-up
do if
question?
there isn't a constant?
nothing? You don't have anything to box then.
So then would it just be like, if there wasn't a -9, would it just be 7x?
Correct. Yep. The next one, 11 plus 8n minus 5. We're going to circle the coefficient. What's our coefficient here? 8. And make sure you circle that positive sign with it. It's a positive 8. We don't want to forget that. We are boxing the constants. What am I boxing here? Abby.
11 and -5.
Good. 11 and -5. Okay. So sign belongs. So signs belong. Signs belong. And here's why recognizing that sign is important. Because when we now combine like terms, I only have one n term, right? There's no other n's here. So that's not going to change. What's my constant going to be after this here, Blake?
8n plus 6.
Good. It's plus 6. Oftentimes, folks see the 11, they see the 5, and they put plus 16. But because that 5 is negative, then it's going to be 11 minus 5, which gives us positive 6. Okay? Remember, you can add and subtract things in any order. So you could rewrite this expression to be, 8n, move that positive 11 on the other side of it, and then the minus 5 there. Here it's easier to see what you're actually doing, 11 minus 5, right? But if you look at it the way it's written, understanding that negative sign belongs to the 5, 11 minus 5 gives us positive 6. Okay? If you don't understand that, it's going to come back and bite you again and again and again. Because this is a negative 5, a minus 5, that sign belongs to it. When you combine those terms, you have to combine 11 and a negative 5, which gives you a positive 6. Okay? So 11 minus 5. The next one. Circle our coefficients. Here's a 2, positive 9, negative 13. Boxing the constants. Positive 13.
That's a constant?
That's a constant. Doesn't have a variable.
Oh.
Okay? Those constants are those numbers without variables. We didn't underline like terms on the last one. I didn't follow my own directions. We'll do it here. Okay?
So like terms are without the variable?
Sorry?
Like terms are without the variable?
No, they're with pony.
Like terms,
Don't have a variable.
sometimes they do. Like in our first one, 3x and 4x. Okay? In our second one, we didn't have any other n's. So we were able to combine the two terms that didn't have a variable, right? What are the like terms going to be in that third one? What are we able to combine here? Camille.
2y, 9y, and negative 13y.
Good. 2y, 9y, and negative 13y. Essentially what we're doing here is whatever y is, we have 2 of them. We gain 9 of them. We lose 13 of them. At the end of the day, how many y's do we have? Negative 2. Good. Okay? So negative 2y. Jeffrey, turn around, please. And then our constant, that plus 13 that we can't combine anything with because it's our only constant, is going to just come along at the end. Okay? Any questions on this? Okay. Can I borrow your, sorry, I got to see it. Woo, there's more. Okay, we'll cover that tomorrow. Your homework, and you have 15 minutes. Let's play the number game tomorrow, folks. It's been a long time. You have 15 minutes. Finish the rest of this page here, page 28. There are 6 of them to do. Make sure you are circling the coefficients, boxing the constants, underlining like terms, and then simplify. Is there another one you want to talk about before you work solo that looked particularly worth our time? Tony?
The last one.
Of course, the last one. Okay, let's start by circling our coefficients. Anything that comes before a variable, we have 4, negative 7 is a coefficient, positive 2 is a coefficient, negative 9 is not because there's no variable with it, negative 3 is a coefficient, and positive 13 is a coefficient. All right? A coefficient tells us how many of a variable we have. So it's got to have a variable with it. We are boxing negative 9 because that is our lone constant. And now when we underline like terms, I'm going to have to use 2 different colors. Why is that? Why is that? Okay?
There's 2 different variables.
2 different variables. So 2 different sets of like terms. Kind of like with the lamps, chairs, and beds, right? I have 3 different variables. Here I've got 2 of them. So I've got a 4x. What else gets underlined in red? That is a like term that can be combined. Camille?
2x.
The 2x and
Negative.
the negative 3x, exactly. Okay? Then for my other variable, I'm going to go with blue here. Negative 7y, what gets underlined in blue then as well? Someone new perhaps that we have not heard from yet today. What else gets underlined in blue? Full.
Negative 7y.
And
Oh,
13y, exactly. Right? So now when we look at how many x's we have, I've got 4 of them. I'm gaining 2 of them. And then I'm losing 3 of them. How many x's do I have in all? 3. 4 plus 2 is 6, minus 3 is 3, right? So 3x. Now I go to my y's. I start with -7. Remember that sign belongs to it. So it's not going to be 20y. It's not 7 plus 13. It's -7 plus 13, which equals what?
4.
6.
6. Positive 6, right? So it's 3x plus 6y, and then my lone constant, lonely thing, just like Mr. Schultz on a Friday night in high school, -9, right? Now, you don't have to write it in 3 different colors here. You could just write it as one expression, but 3x plus 6y minus 9. So pay attention to your variables. Pay attention to the signs, because I guarantee you, you can see why you get the wrong answer if you didn't include that negative sign with the 7. You don't have 20 y's. You only have 6 because of that sign. Okay? All right. Feeling good?
Yeah.
Off to a rocking good start here. Okay. Homework for tomorrow. Make sure you're circling and boxing and underlining, doing all that stuff. And that's how I'm at.
Oh, for goodness.
Guys,